Thank you for joining us today. Today's topic is AI and the enterprise. So, just quick show of hands: how many here are doing anything with AI today in a work context? Raise your hand. Cool. All right. How many are doing it kind of individual contributor stuff? So you're doing it for work, but you're sort of doing it on your own. It's not something that's embedded into your processes. Kind of show of hands. It would definitely be me. How many of you all are actually embedding that into your processes? So I know Cheryl over there is, a few others. Cool. So what we're going to talk today is about kind of what the difference between those use cases are, and specifically how to take advantage of this in the enterprise itself from a process standpoint. So just a quick 10-second commercial on who we are. De is a cloud managed service provider. We are focused exclusively on Oracle applications. So the goals for the presentations today is one, I want everyone to have kind of a high level understanding of what at least a few kind of use cases for enterprise Gen AI is. I want you to have a good basic grasp of what the building blocks are, and then understanding or at least being able to talk somewhat intelligently about deployment models and which ones are right for your organization. So topics, we got a lot of topics, and this is probably very ambitious for an hour session, especially given the fact that we got a little bit of a late start here. But we're going to hit these all very quick. So the main thing to understand with most of these topics is this literally could be a 2 week class that you're taking somewhere doing a deep dive on these. So we are going to hit these at a very, very high surface level. But it's important to understand a lot of these because it helps inform the approach that your organization is taking to your Gen AI strategy. There's also going to be a lot of stuff that we're just not going to talk about. So, for instance, fine tuning. We're not going to delve into that primarily because that's probably not going to be an appropriate use case for most of you out here. So, what is a large language model? So, I've jokingly got here on the screen someone living under a rock. Chances are, unless you are living under a rock, you already know what a large language model is. Everyone here using Chat GPT? Anyone not use Chat GPT? That's probably a better question. I think we had four people in the audience that hasn't. So for a technology that really didn't exist, wasn't on the public consciousness 2 years ago, that's a pretty amazing stat. But what is a large language model at the end of the day? And really all it is how many people have iPhones or Android devices? I'm sure we don't have too many flip phones here. So whenever you're typing a message in your phone, it comes in, it predicts what it thinks the next word you're going to want is. And more times than not, it's right. And that, in essence, is what a large language model is. It's looking at the previous words that you've typed in, or in the context of a large language model, a token, and it's predicting what is that next token going to be. And a token, in most cases, is going to be a word, but sometimes it can be a group of words, or it can be suffixes, it can be prefixes, it can be punctuation. So a couple examples. All of these are tokens. For like really big, uncommon words that you'll see very infrequently, it's probably not going to be a token within that large language model. So in that case, what it's going to do is it's going to break it up into several different tokens it has and try to piece the meaning of that together. I practiced about 10 times saying this to try to get it to roll off of my tongue. I'm not even trying. And then groups of words can be tokens. So like thank you, thank you, thank and you are always found together. So it's treated as an individual token. So literally all a large language model is doing is predicting what is that next token based on the previous information that it's been provided in what's called the context window. So different models, and I'm listing a bunch of different models out here, have different sizes for tokens. And you can think of this as your working memory. So how much information can you store and can you pass to that large language model? And generally the larger the amount of tokens it can handle, the more sophisticated that model is going to be. So, I've got pages of text. When this first came out, really something between 5 to 10 pages of information was about all the LLM could remember. So if you were having an extensive conversation, you might feel like it was having some cognitive difficulties because it would start forgetting stuff that you had talked about earlier. But as these newer models come out, these context windows keep getting more and more large. And this isn't just important in terms of the end user talking with the model themselves. It's also very important in some of the other techniques that we're going to talk about later, where you make the model useful to your enterprise. The kind of the really outstanding ones that we've got right now are kind of what's recently come out with Claude from Anthropic, where literally 500 pages of text is what you can store in your context window. The flip side to that is the larger these context windows are, the more computationally intensive this is, the more expensive it gets, the slower it is. So when you're thinking about it for your enterprise, you don't have an unlimited budget. So you really want to figure out what is that right size context window that I need. Smaller context window, the less expensive, the faster everything's going to run. So, a foundational model. So, the previous slide, I had several models listed. Those are all foundational models that someone else has built. In essence, what it is a kid graduating from college, from university with a bachelor's or maybe even a master's degree that has this massive broad level understanding of almost everything that's taught there at college. They have no real depth necessarily, but it's like the ideal candidate that you as an organization probably are looking to recruit. But they don't know anything about your business, about your industry in most cases. So how are these models built? Literally large piles of text. So this link I've got here is to something which is literally just called the pile, which is a bunch of different sources of text that most of these models started with. There's also other sources that they use to augment. And what they do is they keep feeding this through the model back and forth, saying, okay, which words within all of this text tend to be associated with each other? What group of words go together? And as they keep feeding this through the model, they're starting to tease out what the actual semantic meaning of these words are. And we'll get a little bit more into this later in the presentation. So how much does a foundational model cost? So, when I first started looking at large language models, my first reaction was, I want to build one. I want to do this from scratch. And then I started doing a little bit more research into it and discovered, this is millions of dollars. And, our CEO at Denovo, he's very excited about artificial intelligence. He's not excited to the tune of letting me build my own foundational model, though. And I'm going to guess that's going to be your all's experience too. I think IBM in their keynote yesterday talked about, unless you're Bloomberg, you're probably not doing this on your own. It doesn't make sense to do it on your own. You're going to use one of the models that are already out there. And the cool thing is there are a lot of open weight, open source models from really huge companies out there that are available today to use. Meta, IBM 2 or 3 days ago just open sourced all their models. Cohere, Mixtral AI, Elon Musk's XAI. The Grok model is out there. It's publicly available to download and use. And you can take these models and figure out which one best fits your use case. And ideally, the smaller the model you've got, the more efficient, the more cost effective it's going to be. But there are trade-offs, and we'll get to some of those trade-offs in just a moment. So diving into what exactly these models are, they're basically a collection of parameters. And probably the best analogy to parameters are neurons in the brain. So obviously, the more neurons that you have in the brain, the more complex information that you're able to encode within those neurons. So the human brain has 86 billion neurons. So think of those as parameters. So where do we stack in all of this with large language models? Well, right now we're sort of in the middle of the heap at the 86 billion parameters. So kind of on the very low end, Microsoft about 2 weeks ago released Pi 3 Mini. It's a 3.8 billion parameter model. And the idea is what I talked about before. AI is very expensive. Inference is very expensive. Most of you, if you had ChatGPT 4.0, the actual model, the actual weights, you couldn't afford to run it. It's too expensive. I think their OpenAI is spending something like $700,000 a day to run that. So one of the challenges that Microsoft and other companies are taking on is how can we get something much smaller, much more efficient that you can really do it yourself within your organization, but it's giving you the answers, it's giving you the responses that you're looking for. The Llama 3 models for Meta came out just a couple of weeks ago, and absolutely phenomenal what Meta is doing. They're really giving OpenAI a run for their money. The Llama 2 models, to kind of put this in context, the Llama 2, the previous generation, they had two different models, 7 billion parameter and a 70 billion parameter model. When Llama 3 came out, they had two main models of that as well. They had an 8 billion, I'm sorry, Llama 3. They had an 8 billion parameter model. They had a 70 billion parameter model. Their 8 billion parameter model for Llama 3 outperforms the 70 billion parameter model from the previous generation. And so basically, things that most organizations probably couldn't afford to do just 6 months ago, where you would have needed Llama 2 70 billion in order to do it, you can now do with this 8 billion parameter model. So it's amazing how fast this is going. I mean, I was literally making edits on this deck up to literally a couple minutes before we started. And some of it within the last couple of days is just because things are changing that fast, where I have information in here that's already out of date. So we're going to stop here for a second, and I'm going to get some audience participation. So I want everyone to read the question at the top. This is a prompt that I fed into an AI system, and I asked it for a response. And I want you to, like I said, read it over, and you're going to pick either answer A or answer B. So I'll give everyone just a few seconds to read that over. All right, so if you are answer A, raise your hand. So we have 2, 3 hands, 4 hands. Yeah, you're just copying Cheryl. I don't believe that one. Okay, answer B. Raise your hand. All right. Cheryl, can you stand up and tell us why answer A is the correct answer? I love her. Yes. So this is actually a famous problem from behavioral science known as the Linda problem. This was made famous by Nobel-winning economist Daniel Kahneman, and it's something called it's dealing with something called the conjunction fallacy. Anytime you put an and in there, something becomes less probable. So you got two events, and if you got an and between them, either one of those events is more probable than both of them together. So what I did was I went through a series of different models asking it that question and I scored it. They either got an A, meaning they got the answer right off the bat, or I gave them a C if they gave me the wrong answer originally, but then I said, think of this in the context of the conjunction fallacy. Do you want to change your answer? And if so, explain to me why. And then they got an F if even after that additional prompt, they still gave me the wrong answer. So we had a couple Fs at the very top, the Mistral 7 billion parameter model and Meta's Llama 3 8 billion parameter. In both cases, even with that additional information, still failed. For C's, Llama 3 70 billion parameter, so trained by the same company, the same approach. The only real difference between the 8 billion and the 70 billion parameter is just the number of parameters they were using, the parameters and some of the an expanded data set. But notice that with more parameters, it eventually got the right answer right. The only one that got it right off the bat was OpenAI ChatGPT 4. ChatGPT 3.5, it got it wrong, and then I gave it the additional prompt, it got it right. ChatGPT 4, it came back and it said something like, oh, that's a great problem. I love the Linda problem, which is what it's known as in behavioral sciences. And it expounded on it. It not only recognized the prompt that I gave it, it intuited what I was trying to do, and then called me out with all the details. And so OpenAI's is their model is estimated to be something like 220 billion parameters. We don't know this for sure. They don't publish those statistics. But the bottom line is and it's a little bit of an oversimplification, but the more parameters, the more sophisticated the model, the more nuanced the model. I also love with Mistral how once I gave it the additional prompt, it's like, oh yeah, that's right. And here's the mathematical formula to prove it. So the individual contributor versus the enterprise. So right now, everything that we've been seeing with large language models have all been focused around the individual contributor. So things like code generation. So I do a lot of programming. I can tell you I am way more efficient using Copilot, using ChatGPT than when I was before on my own. I mean, something to the tune of like 3 times more efficient in what I'm throwing out. Also, my code is so much better documented than it used to be. Test cases for testing the code, things like contract review. So you've got a contract from somebody, feed it into a large language model, ask, hey, what are the areas of this contract that I should pay attention to? Is there non-standard language here? Creating content, writing articles. One that I've really liked doing is I'll go on long drives and I'll actually do ChatGPT 4. I'll put it into audio and I'll sit there and I'll have conversations on topics that I want to know more about. and I'll ask it about it. It'll tell me, and then I'll try to paraphrase the information, and it would be like almost, but you got these three things wrong. And it's amazing how fast you can get up to speed on topics that you don't know as much about using it. Brainstorming, sending emails to customers in the voice of yourself. I mean, individual contributor has never had it so well. But the key to why this is so successful is everything that's coming out of that model, you as the human are providing supervision on. It's either like, yes, this is right. Hey, that code you gave me was 95% right, but I still needed to tweak it a little bit. It wasn't perfect. Whereas when we're talking about the enterprise, we really need about as close to perfection as you can get. So a couple things to think about in terms of individual contributor and governance. You need to have internal policies dealing with how your employees are using this. And the bottom line is they are using it, whether you know it or not. Our company trade secrets becoming somebody's training data? Depending on what model that you're using, what information that you're feeding, there may be proprietary information that's showing up in the next generation of the LLM model. Because everything that you do, except with some of the models that'll let you opt out, that all becomes training data that they're going to use. And then what are the rules of engagement? Our approved model is X, whatever it is. And you want to make sure that it's configured not to save logs, and make sure that its privacy policy has already been vetted internally. So on the enterprise side, what are some of the exciting use cases? Well, we heard about MRP the other day within JD Edwards, and I'll have to tell you, I was totally geeking out on that. That was some pretty cool stuff. Some other ones though with large language models, asking it questions like where's my order? Why is my performance so slow? Can I get a price break if I do a order at a quantity 100? How many widgets are currently available? Place this order on hold. Or thinking in context of employee self-service, how do I change my withholdings? Hey, I need to file a sexual harassment complaint. How do I do that? What's the process? And in a lot of cases, if you think about a chatbot, someone's going to feel more comfortable talking to the chatbot about this, asking it, than necessarily going to an actual human in HR. To at least understand what the options are, what the process is. I want to file a PTO request. Now, this one, as soon as someone rolls this out successfully, I will sign up as your first customer. I want to give you my pile of expenses, and I want you to do my expense reports for me, please. Another question's about organizational policies. Hey, I'm flying international. Am I allowed to fly business class on that? You can basically make all of this information very quickly, very readily available to your employees. So, what are some of the challenges? And I apologize for how small the font is here, but really, it's falling into kind of four broad buckets. The first is accuracy. Is the response factually correct? And there's really kind of three different areas with that. The first is hallucinations. Most of you are probably familiar with those, with that, where literally the model just starts making up stuff. But related to that is kind of what I was talking about with my presentation, where I'm like, some of my slides are already out of date before I'm presenting them. Well, staleness. So information that's in the model that was once true. Like it was funny when ChatGPT first came out, you asked it who the president of the United States was, and it would say, as of my knowledge cutoff date, it was Donald Trump, but I'm pretty sure that's changed. but I can't tell you anything beyond that. So you've got the problem with staleness of data. How do you make sure the information in the model is current and relevant? And then attribution. Where did this information come from? So sometimes the model will know something, but it has no idea why it knows it. We have no idea why it knows it. And if you don't know what that attribution is, you really don't know, can I actually trust this information or not? Internal policies. So are we complying with the internal policies? And if so, how are we enforcing it? Security. And this is really a big one if you think about in a context of an LLM. So it may know a piece of information. Is it allowed to give that piece of information to an end user? Is that end user authorized to know that information? And right now, there's really no way to secure the front end of a large language model. So it really gets reduced down to kind of that lowest common denominator. What am I comfortable with everybody knowing? So we talked about security compliance. Let's say you're in Europe and you're subject to GDPR requirements, or maybe you're doing something with the Department of Defense. You're subject to ITAR requirements, or HIPAA is in play depending on your application. How that data is stored could be creating regulatory liability for you. So these are all things to think through when you're thinking about what your actual use case is. One thing I always advise when you're thinking about large language models, assume it is the drunk guy at the bar trying to impress some lady by telling all your company secrets. She looks very impressed, doesn't she? So kind of risks to the enterprise of all of this. Leaking of confidential data. There was source code from Samsung that ended up in one of these large language models. They were in a panic about it. How do we get that back? We don't want this to be out there and available as training data. Contempt of court. How many people heard about the lawyers in New York that were using ChatGPT to write a document for the court, and it started hallucinating case law very convincingly? But they were all found in contempt. Another case study, Air Canada. Who heard about Air Canada's chatbot? This one was kind of fun. So Air Canada is doing some very sophisticated stuff, and the harm they did to themselves with this was relatively minor. So my advice to Air Canada is double down on what you're doing. It's awesome. But what the scenario was someone was talking to the chatbot and asked, "Hey, I'm doing travel for bereavement. Can I get a bereavement rate after the fact? After I get back from the funeral, file the paperwork, get the refund." The chatbot said, "Yes, you can do it," and then gave them a link to Air Canada's policy, and the policy said, "No, you can't." And so that user ended up taking them to court in Canada and won. And the court enforced them to honor the policy that the chatbot made up. So something to think about. You want to think about, am I out in airfare, or am I potentially out several $100 million? And really think through what the consequences are for when the chatbot gets it wrong. Because the chatbot will get it wrong at least as often as a human is going to get it wrong. We just have a lot more tolerance for humans making mistakes. So thinking about hallucinations, thinking about the fact that these chatbots don't have specific industry knowledge, what do we do about this? How do we address this? Well, one of the best ways is via something called RAG, or Retrieval Augmented Generation. Who here is familiar with RAG? Show of hands. Okay, a few people. So the best way to think of RAG is you're the kid that brings the cheat notes to the exam. RAG is basically a way to give supplemental information to the chatbot. So before where I talked about the context window was important and why you might want a larger context window, because what you're doing is you're literally taking the original question, you're looking it up in your internal knowledge base, and you're taking supplemental information that you're appending to the end of it and saying, hey, and as you answer this response, this additional information might be useful in crafting that answer. So a very, very powerful technique. It's a way to ground the large language model factually in your data. So basically taking that user prompt, it's going to take the prompt, run it against a vector database. The vector database is going to come back with those additional items from your company's repository, feed it into the large language model, you're going to get the output. So in this next example, I'm running Llama 8 billion parameter model. I asked it the question, what is de novo? And it comes back with an answer that maybe a couple industries we do something with, but the answer is like materially worthless. Unfortunately, we were not a major part of Meta's training data. We're working on fixing that. So after RAG, so what we did with RAG is I took all of the content from our website, turned it into what are called embeddings, stored it into a vector database. And so when I said, what is de novo? Now it grabbed that information out of the vector database, it appended it, and said, hey, this might be useful in answering the question. And it comes back specifically with the information telling us who de novo is, what it is that de novo does. But not only that, notice at the bottom, it's providing a citation. Where did this information come from? What is the attribution of this information? So I talked before about a vector database. So what is a vector database? And this is one of the most exciting things in large language models that makes it useful. This is the heart and the soul of RAG. And it's the idea that we've got the word apple, and by itself, we don't know, are we talking about the fruit? Are we talking about a technology company? Or are we talking about a classic computer? Well, depending on what the words are surrounding it, so let's say in our vector database, I've got equal number of entries for all three of those. So the word apple by itself is going to basically be triangulated in vector space between those three. As I add additional words on either side of it, it's going to start moving it in one direction or the other. You know, am I talking about the fruit? Am I talking about the company? So it's not just about the word, it's about the meaning behind the word, the context. So it'll take your prompt and it will basically say, okay, where should this prompt exist in vector space? And nothing else is going to be there. It'll be empty because that prompt is probably unique. But then it'll ask the question, what are the nearest neighbors to that prompt? Because that's probably the information that I'm looking for. And then basically take that information and return it back. So again, what we were talking about before, the user prompt looks up in the vector database, large language model output. So we ask, who is de novo? And it returns back the 5 closest matches, the nearest neighbors it finds in that vector database to that, passes all of that information into the large language model, giving us the output. So this is really the secret sauce to making large language models work and make them useful within the context of your enterprise. VRAM. This is one of the big issues with running these larger models is the amount of VRAM you need. This is a different type of memory than what you would think about normally in your computer. It's going to be on the GPU. It's ultra low latency, and it's what you need for running these models. So if you look on the right hand side, the VRAM, you can see like ChatGPT is estimated to be 409 gig of VRAM. Go buy an NVIDIA GPU that has that much. Chances are most of you could not mortgage your house and still afford to buy that GPU. So again, the VRAM is hugely important because this dictates how much hardware capacity you're going to need in order to run a particular model. However, there is a solution to some of this, quantization. How many here have ever heard of quantization? I think we have one. So I'll give an example of what quantization is. So let's say I want to take pi plus 20, and I want to store it. So at the very top is floating point 32. Also, for most models, this is what's considered full precision. So if I were storing that number, it would be represented by 32 binary values and 7 decimal points, so 20.141593. So if I go to half precision, now I'm storing this in 16 bits of information. So literally, I just cut my RAM requirements in half. But I'm also losing precision, so I'm at 23.14. Take it down even further, so now I want to do this in 8 bits. So I'm storing the number 23, no decimal points. So here's where it really gets weird. Let's say I want to drop below 8 bits to 4 bits. My data becomes meaningless. So in int4, that calculation stores a 7. In int2, that calculation stores a 1. So obviously, I've got this ability on the first 3 options to round down. And intuitively, I get what's going on there. But how in the world can I have a 4-bit model, a 2-bit model, and actually they're playing with 1-bit models? I mean, how is this even remotely useful? And the way it works is this concept called bucketing. So instead of trying to represent a number now, we take all of the data values that are out there that are roughly going to approximate some normal distribution. And then we have different sized buckets. So where we have the highest variance of data kind of clustered towards the center, we're going to have smaller buckets, and we're going to make them wider as we go out to the edges. And each one of these will store 0 through 7, or our 4 bits for int4. For int2, it's the exact same thing. We're just bigger slices of the overall model. And then there's even 1-bit quantization, where literally everything is this or that. I joke that it feels like this is the model sometimes most appropriate for American society. You will fit in one bucket or the other. So why this is important is this gets the RAM requirements dramatically reduced. So I've got two white papers that Oracle has published within the last month where they're using these quantized models, where now instead of using these massively expensive NVIDIA-based GPUs, you're literally able to do this on ARM processors, on Intel processors. Really making this much more accessible to most organizations. So kind of going back to the Lynda problem that we were talking about before, here's the cool thing. So I tested this with 4-bit quantized models, and it was still consistently giving me the same answers as with the full precision models. And And I don't know if I've got the statistic here. So the 70 billion parameter, Llama 3 70 billion parameter, 2-bit quantized model. So I tested it on that one because I could actually get it down to like 26 gig of RAM and make it just fit in my my consumer grade RTX GPU. And I asked it the question, and it came back. So initially, it gave me the wrong answer, and then I asked it to consider the conjunction fallacy. It came back with the right answer, and it told me why it was right, and that was with 2 bits. I mean, it still astounds me. I was doing this originally to show you why quantization at the very low end just doesn't work. I was blown away by the results. This really is game changing in a lot of ways. So this is kind of looking at it from memory size. So the 8 billion parameter model required 16 gig of VRAM. The 2-bit version only required 3.2 gig. 70 billion parameters, 141 gig of VRAM. The 2-bit version only 26 gig. So the other thing that kind of blew me away with this is the 2-bit quantized version of the 70 billion parameter model outperformed the full precision version of 8 billion parameters, which was not a result I was expecting. So basically, more parameters appears to be far more important than precision. Maybe. We're dealing with very small sample group sizes here. But based on my initial playing, initial experience, this appears to be the case. So deployment models. So when you're thinking about this in terms of your company, think about, what is my use case? Start there. Because everything else is going to flow from what your actual use case is. When you're thinking about the use case, what is kind of the balance between recall and reasoning? So a lot of these really small models are fantastic at recall. You want to find a piece of information, it will give you that piece of information back. And if that's what your use case is based on, you can go with very small models, very low cost, very efficient, very fast. Or is it involved more on the reasoning side? You need it to work out an alternate route for MRP. You need it to do things that are a lot more intensive. So that's going to help determine how many parameters you need, what size model, what size context window, how much information from your vector database are you going to be supplementing to it. How many concurrent users? This is kind of a big one. Are you going to have a couple users per day accessing this, fairly low volume? Or are you going to have 50 users simultaneously, where you need to be able to produce a massive number of tokens per second? How sensitive is the data? GDPR. That's a typo. I never find my typos until I'm presenting. I just find it's more fun that way. Or do you have personally identifiable information? Do you have other information that you can't get out? This may determine whether or not OpenAI is a good option for you, or you need to do something where you are absolutely in control of the data and perhaps even meeting local data residency walls. How do you control access to the chatbot? We talked about some of the security stuff. Generally, when you're first starting to work with this, assume the information that you want to provide to the chatbot is something you're comfortable with your competitors knowing. And kind of your big couple of chunks, you're going to have the large language model, which we spent a lot of time talking about. You're going to have your vector database, your RAG system, and then you're going to have your Oracle ERP system. So maybe using something like Orchestrator to expose your JD Edwards data as a data source that you're making available. So LLM deployment models. So we talked about what the actual requirements of your use case are. There are SaaS-based models like what you can get from OpenAI, from Anthropic, from xAI, Elon Musk's company, or even for Oracle on OCI for that matter. But in addition to those kind of SaaS-based shared models, there's also dedicated models where you can guarantee that your data is not going to be commingled with anyone else's. You have much tighter control over who's potentially seeing that information that's subject to those regulatory restrictions. And then you've also got the ability to build this all yourself. That article where it was talking about how to do it on ARM, running it on GPUs, running it on ARM, running it on Intel. The cool thing with that is pretty much all of these options from the SaaS side to the build it yourself side, you can do these all on OCI today. So pretty cool stuff for your RAG database, same thing. There are SaaS options out there like Pinecone that are available. Oracle last week announced Oracle Database 23AI. I keep wanting to say 23C. 23AI, and it has vector database capability built into it. This can be run in a SaaS model or kind of the do-it-yourself model. And then there's things like Chroma Database, which is open source, free. You just bring it up on Dockers. So, and lastly, your JD Edwards deployment model, and this is largely where we're going to wrap things up today. And we would encourage you to run it on OCI with Denovo managed services. So if anyone would like to get a hold of me, contact me. My information's here. Just scan the QR code. And if you'd like to learn more about Denovo, if you'd be interested in scheduling an AI road mapping session, we'd love to work with you. Hit this QR code. And in the back, I believe we have some handouts, Sam? Oh, we have handouts, a couple recent articles I've done that go into some of these topics in a lot more detail. If anyone has any questions following this, I'll hang around for 10, 15 minutes. I'd be happy to talk. Everyone, thank you so much for your time and have a wonderful day.